Hello, Abisters, especially Claire. Anybody else want to say hello, Claire? Hi, Claire. Claire, I hope you're enjoying your food. And Claire, we're getting a new way rather than this camera because the only way, Claire, to focus this camera is by wrapping on it tight slightly. Let me wrap on it again. There. High tech. It's just amazing. You know, I don't know how many people go live stream, but what do? We whack something with a pen to get it to work. It's just kind of cool. Yeah, whatever works. So anyway, let me just start here to begin with. Volume of a cylinder. Man, it looks terrible. Claire, I don't know if it's going to be worthwhile. It got worse, Claire. Somebody.
Anybody a tech whiz in here?
There, that did it right there. No, I don't think you had anything to do with it, man. It looks really good now. All righty. So Maggie, what is the volume of a cylinder?
Oh boy.
Okay. What do you know is in it has to be for sure? What should be in every meal?
Pie.
Yes. Pie. And you have the base is a what?
R or something.
Yeah, what does R stand for?
Radius.
Okay, what do we do with the radius? Square it.
Yeah.
So that's the area of the base
Yeah.
times the
Pie.
height. There you go. Perfect. Perfect. So, Matt, I have a shell. I'll draw a picture. So, Cole, do you draw those things in 2D art? Okay. You know where I learned to draw this? At meetings. So there's a hole there, right, Matt? So how many cylinders do I have? If I want to figure out the volume of that shell. 2 of them, okay? And so I have an outer shell, right? An outer cylinder minus an inner cylinder.
Yep.
Okay. So here's the radius. I'm going to call that R sub 0 for outer radius. And it has a height, correct?
Yep.
And in this case, with my beautiful drawing, the height is the same for both of them. Okay. And so this is my, let me draw it here. That's my center. Right here is my inner radius, so I'll call it Ri. Are you okay with that inner? So what would I write here, Matt?
I Ri squared times height.
Perfect. Okay. And if I wanted to, I could factor out the pi h. Would you agree? And I would have the outer 1 squared minus the inner 1 squared. Would you agree? Okay. So that is kind of a rough idea of that shell, right? Okay, now, our shells are going to become really, really thin. Okay, so what do you think happens to the inner radius and the outer radius?
The inner would increase and the outer would decrease.
Right.
The outer would stay the same.
Well, if they get thinner, they'd probably move towards each other, wouldn't you think?
Yeah.
Right? Or they'd start becoming closer to one another. Can I say that? Okay. Let's turn to the next page. So what I did here is I called the outer R2 and the inner R1. Okay. So over here, let's make sure I got my notes here. I think I could do it without notes. Let's see. So this is what I said. I said I used R2 and R1. I think that's okay of an idea. And so the volume I'm going to have of a shell, and I'll write it S here, is pi R2 squared H minus pi R1 squared H, correct? And then what I said is, you said it was okay for me to factor out a pi and an H and get the outer squared minus the inner squared, right? You said that was okay, Matt?
Yep.
Okay. Okay, so I'll come back to that. And this is a top view. So what I'm going to see is this. Here's my shell. And this right here, I'm going to call P. And what P is, it's the average of those two radii. So it's in the middle, okay? And this has a particular thickness. And that thickness I'm going to call W. Okay, you all right with that? Okay. So R2 is going to be P plus 1/2 W. Everybody okay with that? So right here, this distance is R2. It's my outer radius. Right here is where P would be, correct? And if this whole thing is W thick, if I go half a W, I get over to here. Okay? And so R1 will be P minus 1/2 W, which is right there. Are we okay with that? Okay. And so now I'm going to slide over again. So hopefully I'm not making clear, dizzy. And I'm going to have the volume of my shell is going to be pi H, and I'm going to put a bracket right here. And I'm going to have P plus 1/2 W squared minus P minus 1/2 W squared. Manu, okay? No? I screwed up?
No, I lost it.
Okay. Do I need to re-explain anything, or are you okay? You're not okay?
I'm not.
Okay. So we have an outer radius and we have an inner radius. Okay. I'm going to say P is the average of those two radii. Okay. So it's in the middle of those distances. And then I'm going to say, okay, that shell has, because I'm going to make that shell very, very thin. The width is going to be headed towards 0. Okay, I'm going to take a limit here in a second. Or more in a second. 3 or 4 minutes. Maybe about 10. Okay. And I can say that that first radius, that inner radius, is that length of P minus 1/2 of W. That brings me to here. And the outer radius is that P plus 1/2 of W. Are you okay now?
Yeah.
Okay, so we're back to here, because I'm going to need you. Okay, because I'm not as mathematically sound as I used to be. I'm going to ask you to expand P plus 1/2 W raised to the second power. And speak slow.
P squared
Perfect.
plus WP
Okay, can I say PW?
what plus 1/4 W squared.
Okay. And I'm going to put parentheses around that, or is that okay?
Yeah.
Minus parentheses. Can you do it again with these?
P squared minus PW plus 1/4 W squared.
And I didn't hear the piranha object, so it must be perfect. Okay. That's why I call you guys when you make a mistake. Okay. I say that lovingly. Okay. If I would collect fish, I would collect piranha. I don't know if that's a good idea either, actually. Alrighty. So, Nevaeh, let's distribute. I will do the first one, okay? Since it's like no work. P squared plus PW plus 1/4 W squared. Now what?
Minus P squared plus PW minus 1/4 W squared.
Ooh, and I'm very happy with that because I get to go to get a red pen, don't I? And I have several in here. Nevaeh, bam, bam.
Woohoo!
Right?
Yeah.
Ooh, sound effects. Okay. And then bam, bam again. Correct?
Yeah.
So, the volume of this shell is what, Nevaeh?
Oh, we're still on me.
Yeah, because you're doing a marvelous job.
Volume of the shell is pi h times 2 PW.
Would everybody agree? Okay. So I could reorganize this. 2 pi, because those are constants. Correct? Right? P, H, W. Why that order? Because W is a thickness. Correct? Okay. And I'm going to have an infinite number of shells. And P and H are going to be functions. Okay? Yes, sir.
So I understand like all that, but like why would you do the shell instead of a washer? Like
What's the advantage?
Yeah.
Okay. So some of the advantages are if you would rotate around the y-axis, sometimes it's difficult to get a function in terms of y, such as y equals x cubed minus x squared plus 14. That would be very difficult to get in terms of y, which you would need to do if you rotated around the y-axis, correct? However, if you rotated around the y-axis and did the shell method, you'd still be able to do it in terms of x. You follow me?
Yeah.
Okay, and so that's an advantage. The other thing is you don't have to worry about forgetting to subtract the washer, because as soon as your rotations, as soon as you integrate from A to B, whether it has a hole or not, if you start at the axes, so like right here, let's use this beautiful picture that I put here. If A is here, oh yeah, get it so Claire can see it. If A is here, there's no hole, right? If it's on the axes. How if it's here and I start rotating that shell around this way, it automatically included the hole. So I never have to worry about it. Okay? And so for two reasons, and you get to decide, okay, because you'll get to problems, you know, like the ones I give you, you'll want to do all the shell method because it's a new method you're doing. All right? For all the other ones, you can say, okay, would it be better to use the shell or the disc and washer method? It's totally up to you, whatever you find easier that gives you the best success. It's just another tool. And there are times I prefer it if I don't want to go through the hassle. It's really, in some cases, a lot simpler, if you can remember it, okay? Usually the hardest part as a teacher to explain is how I determine what P of X is. Okay, the rest of it's fairly direct. Okay, does that answer your question?
So
Okay.
on the AP test, it's never going to say like parallel. It's always going to say perpendicular.
It's always going to, okay, for cross sections, it will always tell you what it's perpendicular to. Okay, for the rest of them, it'll simply say take the area of this region and rotate it about whatever axes you use. And I've had some students that said, you know what, I like the shell method personally. It works well in this case, and they choose to use it and get credit for it. Okay? Are you required to use it? No. Are you able to do it the other way? Yes. But for sake of time, they felt very confident in it. They just put it down, and they came up with the answer, and they got credit for it. Because they didn't have, and usually it was ones where they had to take either in terms of y, put it in terms of x, or take it in terms of x and put it in terms of y, and they didn't want to do that. Does that kind of answer your question? Okay. So this is one shell, right? So I could say, all right, I got an infinite number of volumes I'm going to add up, and I'm going to have 1 to, from I equals 1 to n, I'll have n number of shells. And they'll start from A to B, right? So I'm going to have this thickness of B minus A over n. This right here is my thickness. This is my W. And I'm going to have this P of C sub I, and this H C sub I. Oops, I forgot one thing. 2 pi. So if I look at this, over here I have this, there's my 2 pi, there's my 2 pi, this is my W, this is my P, and this is my H. That's how I used to show my work on my homework. I had arrows all over the place with black pen, mostly pencil, with a lot of eraser marks. Now, if you look at this diagram right here, here's your W, right, your delta X. Here's your height. It's dependent upon the function. I call this a radial function. It has some attributes. It's always linear. It stems, it is the length from the axis to the domain of X. So in other words, here's my radius. It's going to start at A, because I integrate from A to B, don't I? I tell the integration, our domain is only going to go from the interval A to B. Over here, if this was 0, over here are the negative numbers, I'm not using them, am I? So it's going to start out the length of A, isn't it? And it's going to end at the length of B. Well, what's the only thing that's going from the length of A to B? X, correct? So what I do is, if your vertical axis is in the form of X equals A, I don't want to use that. Forget that I used A. Let me pick a different letter. Can I use C? Okay. P of X, if X is greater than C, then P of X is going to be X minus C. If X is less than C, then P of X is going to be C minus X. So let's say this is the y-axis. What is X equal to here? What's the equation of the x-axis? X equals 0. So my P of X would be X minus 0. We're going to be doing a bunch of problems where I'm going to explain that again and perhaps a little bit more clear. Okay? Can I turn to the next page? Here is if you would rotate around the x-axis. So your delta y thick. So it's going to look like this. You're going to have 2 pi from A to B, P of y times h of y dy. Thickness, height, your radius. I'm going to go to the front, and I probably should have put this down. I'm going to integrate from A to B. I got 2 pi. Here's your radius. Here's your height. Here's your thickness. That's always your setup for your volume of your shells. All right? We'll look at an example. An important note I write here is your representative rectangle. Remember how I rotated the rectangles on the screen? Is always parallel to the axis of rotation when using the shell method. So let's find the volume by rotating about the y-axis, the region bounded by this graph and y equals 0. Okay, so it's going to look like this. Let's see. Here is y equals 0. Here's x equals 0. I'm rotating around this because that's the y-axis. And I'm going to find out where it crosses the x-axis. So 0 equals x squared times times 2 minus x. Does that look correct, that I factored that correctly? So that means x equals 0, x equals 2. So my graph looks like this. And here's my rectangle. And it's dx thick. And again, I'm rotating and it's parallel to the y-axis. So this right here will be p of x. And right here, this will be h of x. Am I okay with that? Okay. X is greater than 0. In other words, my axis is always x equals 0. My domain starts at 0 and then goes to 0.5, it goes to 1, it goes to 1.5, and then stops at 2. All those values in the domain are bigger than my axis of revolution, which is a constant, which is c. So it's going to be x minus 0, which is x, and that is equal to p of x. Because you got to remember, I'll use red here. P of x looks like this. It starts here and then just extends. And every time it's wrapping around, correct? And then eventually gets to 2 and it stops. So my integral looks like this. 2 pi. We always start with 2 pi. We're going to integrate from 0 to 2. It's going to be x, because that's p of x, times h of x, which is 2x squared minus x cubed. So here's p of x, here's h of x, here's w, my width. So it's going to be 2 pi, 0 to 2. And this is probably one you do by hand. 2x cubed minus x to the 4th. I hope that's right. Does that look correct? So I got 2 pi. My antiderivative is 1/2 x to the 4th minus 1/5 x to the 5th from 0 to 2. Still look okay? 2 to the 4th. 2, 4, 8, 16. Half of 16 is 8. Minus 32 fifths. 40 fifths minus 32 fifths is 8 fifths. I'm saying I get 16 pi over 5. Is that what you got, Austin?
Yeah,
Is it? Or are you just saying yes just to make me feel good?
that's what I got.
Okay, good. Because you would not have a problem telling me I'm wrong, right? In your heart, you're a piranha, aren't you? I am. I took a color test, a personality test, a long time ago. And they give your characteristics color. I'm a yellow. Which means,
What's the yellow?
I'm going to tell you, okay? I want to help you. I want to help you by telling you what you're doing wrong and tell you how to do it correctly, okay? I didn't realize there are people that are irritated with me. And plus, you don't care that people are irritated with you. That's another thing, okay? So like early in my marriage, when I would tell my wife, well, you don't want to do it this way. You want to do it this way instead. Why she couldn't figure out why she wouldn't want to know that. till I took this personality test. And there was some administrator doing statistics. Wrong. Of course, I'm taking notes. So after their presentation, I go up to them, tell them what they did wrong and what they should be doing right. They were not happy with me. Why? Because I'm a yellow person. There are also green people. Green people are the opposite of yellow people. And that, guess what? You made a mistake. That's okay. You'll be okay making mistakes. Life will go on. You'll continue making the same mistakes, but I still love you. I am not a green person. So anyway, let's take a look. We're revolving around the x-axis. So it's the region between this, so it's going to look like this. Here's y equals x. Here's y equals x squared. It looks like this. And they intersect, so I could let them equal to each other. Again, this is one I can do by hand. So here's 0, here's 1. I always call this a banana problem because it looks like a banana to me. It's around the y-axis. Does it say that? Which is the equation x equals 0. That bothered me, by the way, for a long time. It's the y-axis. And x defines the y-axis. Should say y equals something. Well, then I'd plot the points. 0, 1, 0, 2, 0, 3, 0, 4. X is always 0. Tristan, it still bothered me. We're talking about years. So here is my rectangle. It's skinny, isn't it? It's dx thick. Here is p of x. Here is h of x. Claire, I'll make it a little bit bigger for you. I wonder if she's actually going to watch this. I haven't gotten any response from her, so she's not watching it. Oh, yeah, she's eating. Okay, so it's going to be 2 pi. Are we okay with 2 pi? Integrated from where, Ray? Perfect. Perfect, Ray. Okay? You get a choice, Ray. You want to do p of x or h of x? What do you feel most comfortable with? You want me to select one for you? You want to do both of them? Okay. H of x. How do you figure out that length? Subtract what? Oh, by the way, Cole, somebody sent you a text. I felt it. Okay. It's a larger buzz than what I get. Okay. Go ahead. What? X minus x squared. So here I have x minus x squared. P of x, Austin, what is it?
P of x is x squared minus x. Oh, sorry, x minus x.
X minus 0. Because it starts here and works its way out. It moves. Does everybody see that? P of x is, I think, tough. It starts at the axes, or it starts at A and moves out. Okay? So it's going to be x. So we get 2 pi 0 to 1 x squared minus x to the third dx. And just to keep people involved, Maggie, antiderivative.
Oh, you're asking me.
Yeah, what is it?
1/3 x to the third.
Third, you said,
Yeah.
not fourth. Sorry.
And then 1/4 x to the
Yeah, I got thinking ahead. From 0 to 1, correct? And that gives you 2 pi times what? Just give me the fractions.
1/3 and 1/4.
3 minus 1/4. Do you know what 1/3 minus 1/4 is? What's my common denominator? 12.
So it's 1/12.
1 over 12, so I can put 12 on the bottom.
Yeah.
So I get pi over 6. Yep. Do you agree with that?
Yep.
Which is about a half, about 0.5. A little bit bigger than 0.5. Is that what you got, a little bit bigger than 0.5? Yes, sir.
So is x always just going to be like x minus a or a minus n?
That's exactly what's going to, well, okay. Whatever the equation of the axes is. So I use C.
Alright.
So x minus c or c minus x.
Whatever the axis is.
Right.
X minus
Right. That's why if you use A is our lower bound, so that's not a good choice. That's when I wrote down A, I kind of did a silently swear to myself. Hopefully you didn't hear it. Okay. Because I said the other word for poop. I like poop because it's a palindrome when you think about it. Okay. And I've had a lot of positive experiences. I know people find it negative, but I don't.
Yeah, like your Catholic.
Yeah, exactly. When I was 3 or 4. 3, I think. It was shortly after that I fell into the septic tank.
And that's a fun experience.
Okay. All right. Cylindrical shells that are by rotating about the x-axis, and it's the square root of x. And the square root of x looks like this, from 0 to 1. And we're revolving it around this, correct? Right, that's the x-axis. Region under the curve. And they look like this, because they got to be parallel. Ooh. Nathan, how thick is my rectangle? Yes, dy. So that means I'm going to integrate on the y-axis, aren't I? Correct? So here's 0. What's this number right here? 1. How'd you get that? Yes. Okay. Do you have somebody talking to you inside there? Occasionally. What, male or female? Non-gender? Okay. Why did that person choose 1, or did you just think of that yourself? Well, if you plug in 1 into here, what do you get? 1. There you go. All right. So you want. So what this is now, this right here is going to be P of y. Does that make sense? Because it goes from the axes to that rectangle. This is going to be H of y. That length, that height of the rectangle. So I'm going to integrate 2 pi. According to Nathan, he's correct, from 0 to 1. dy, because we're dy thick. What's h of y? Jack. No.
Oh no, h of y is square root of
Everything has to be in terms of y. Y squared equals x. Okay. Is that what that length is? No, it's not. You know it's not, but you're not quite sure what it is, right?
y.
1 minus what?
Y squared.
Yeah. H of y equals 1 minus y squared. So this is 1 minus y squared. Perfect. What's p of y? Well, you want to, or you want me to pick on Jake Ackerman? Okay, Jake, do you have an idea what it is? It's got to be linear all the time, because it starts here and moves up the y-axis. So it starts being that long, and then it's that long, and then it's that long, and then it's that long, right? It's swinging around, correct? So this time, my input is from 1 to 0, correct? And my equation is y equals 0 right here. So it's always, so my c is 0 here. So what do you think it is? Remember what Jack said? Is it always y minus c or c minus y? And I said yes. There's not y, because it's a linear thing. Because it's going to go, pardon? Anybody want to help them? Just y. It's y minus 0. Okay? So I'm going to have 2 pi, 0 to 1. I'm going to have y minus y cubed dy. I'm going to have 2 pi. I'm going to have 1/2 y squared minus 1/4 y to the 4th. Does that look right, Jake? Okay. So I get 2 pi times 1/2 minus 1/4. Does that still continue to look correct? And what's 1/2 minus 1/4? Times 2 pi, do I get pi over 2?
For the h of y, why did it become 1 minus y squared? Where's the 1 come from?
The 1 is here. This is y squared here. This is x equals y squared, and this is x equals 1.
I see.
So it's going to be 1 minus y squared. Y squared is this length. Okay, good question. All right, let's take a look at this one. Here's the graph. It's going to be about x equals 2. So if I graphed it, I get 0 and 1. Does everybody see where I got 0 and 1 for that graph and why it's a parabola going down? Can I make that jump right away for everybody? Here's the equation. X equals 2. Here's my rectangle. It is dx thick. This is p of x. The longest that p of x is 2. Do you see why? The shortest that p of x is 1. Do you see why? Can p of x be 1.5? If the longest is 2 and the shortest is 1, can p of x be 1.5? Yeah, it could be 1 3/4. Okay, so think about what the equation is that gives you that. So I'm going to have 2 pi. I'm going to integrate from 0 to 1 because that's my domain here. That's the bounds of my region. It's only the region. This will be my hole, which will be included in the rotation of the shell. Does that make sense? So Tristan, h of x, would you agree? That's this right here. That's the height. Okay. What is the equation for the height? Not sure? Yeah, you can always phone a friend. You have your phone, or are you going to just ask her? Okay. It's going to be x minus x squared. Because whatever that x is, that gives me my height, correct? Now, Tristan, you already used phone a friend. Is that show even on anymore? Who Wants to Be a Millionaire? Do you guys even know what comes from that? Okay. Does anybody have an idea what P of x is? Is it x this time? Is it x minus 2 this time? It's what instead? It's 2 minus x. Because x can only go from 0 to 1, right? So this length, when it's all the way over to here, that's the longest P of x can be. This is the shortest that P of x can be. It's going to be between 1 and 2, correct? So this is, remember when Jack asked, okay, 2c minus x. He said, is it going to be x minus c or c minus x? It depends whether the value of the axis is greater than the domain that you've created, right? The a to b interval that you have. So over here, I'm going to have 2 minus x times x minus x squared dx. The hardest part about these is setting it up. I think, personally, the hardest part is wrapping your head around P of x. You don't need me to do the rest, do you? So we're going to work on this today and tomorrow. Okay? Alrighty? Claire, do you want me to finish this? Who would you like to finish this, Claire? I agree. Renee, you want to expand that for me? It's Claire's issue. Oh, it's a minus, is that minus 2x squared you said, didn't you? Correct? Yeah, and I wrote it down wrong. I get 2 pi times, this is x squared, minus x cubed, right? Plus 1/4 x to the 4th. Renee, does that look correct? Did I do the antiderivative okay? And I'm going to figure that out from 0 to 1, which are really nice numbers. Because the 0 is really a waste of time to look at, correct? And when I put 1 in there, 1 minus 1 is 0. So I'm going to get 2 pi over 4, which is pi over 2. Would you agree with that? The calculus part's easy on this one.